Okay, we have one more topic in this Unit 7 here. Well, one more after this as well, but here's the next topic that we need to talk about today. Most of these questions are going to actually be word questions, so you're going to answer them in words, but they're really easy if you kind of know what you're doing and you're talking about here a little bit. And so the first thing is to recognize the difference. Take a look at question number 3 and question number 4. So this is asking for what is the probability that our value x is between 9 and 14. All right, so probability, this is an area. So this is in essence asking what is the area between 9 and 14. And then in number 4, notice how the question is in essence the same thing. What is the probability that that x is between 9 and 14? However, you'll notice that the keynote difference between these two things is this. In number 3 is just a straight up x. And number 4, this is an x bar. All right. So there is a keynote difference between these two things. And so this is what we need to talk about before we get doing our problems. Again, most of these answers are word answers, and they're pretty darn easy. And so let's just figure it out. Okay. So the difference between an x and an x bar, as far as this chapter is concerned, x's are an indicator that you are working with population information. You know everything there is to know about everything. You have population kind of information. X bar is an indicator that you're actually working with a sample. Okay, you're actually working with a sample. All right, so you're not working with the population anymore, you're working with a sample of the population. And things change just a little bit. Okay, when you have an x, your average mu is just straight up your average. Okay, it is what it is. And your standard deviation is your standard deviation. However, when you're dealing with a sample, the average, ironically enough, is the same. However, the biggest difference, and this is what we really need to talk about, is the standard deviation. The standard deviation of a sample is your regular standard deviation divided by the square root of n. Okay, it's your regular standard deviation divided by the square root of n. That will get you a standard deviation of a sample. Okay. So it's going to be a little bit different. So the averages are the same, standard deviations. So when you're say you're going from x down to an area, and you need to first turn that into a z-score, or it's x minus mu divided by sigma. In essence, you're going to do the same thing between a population and a sample. However, when you have a sample, you have to use your alternate standard deviation. You first need to figure that out before you can get the correct numbers coming out of it. And then it's just business as usual. So you're going to have to get a new standard deviation. Right? What differences can you expect when you create a sample? All right, so I'm going to draw 2 pictures here real quick. And this is what you can expect. Of a population, your distributions will look something like this. Okay, this is of a population, aka x's. And then when I create a sample, this is what happens. All right, so you'll notice that the average is the same. The average is the same. All right, again, samples are x bars. But there is 2 obvious differences that you can see. 1, samples are taller, and samples are more narrow. And again, we just have to learn how to say this in kind of like scientific thought, in mathematical terms. So again, the way to describe height of a picture is that is the relative frequency around the mean. And the width of this is the standard deviation. So a way that you would describe something, like describe how is a sample different than the population? Well, a sample has, I'm going to say that it's taller. It has a larger relative frequency around the mean. And it has a smaller standard deviation. Okay, when you describe something, in my class anyways, and you're describing a curve, you have to mention both. You have to mention relative frequency around the mean, and you also have to mention standard deviation. All right, so relative frequency around the mean you have to mention, and you also have to mention standard deviation. When you're describing this larger and smaller, this is pretty easy. These are always going to be opposites of each other. So if you have a larger relative frequency around the mean, you're going to have a smaller standard deviation. If you have a smaller relative frequency around the mean, you have a larger standard deviation. Okay, and last but not least is just mathematical things in general. Okay, I'm interested in how is this answer affected? And what I have is I have a division, A divided by B or something like that. If you have a numerator or a number sitting up front, I'll say A, B divided by C actually. If you have a number sitting out front, like this letter A, that is considered to be a multiplication number. If you have a numerator, such as the letter B, that is also considered to be a multiplication. If you have a bottom number, it is considered to be a division. All right? If you multiply by a big number, okay, if you multiply by a big number, your answer is going to get big. If you multiply by a small number, your answer is going to get small. It's called a direct relationship. So if I multiply by a big number, my answer is going to be big. If I multiply by a small number, my answer is going to be small. Now with a division, it's an opposite. So if I divide by a really big number, my answer is going to be really, really small. And if I divide by a really small number, my answer is going to get really, really big. Okay, so new formula. When you're dealing with X bars, make sure you get a brand new standard deviation before you can continue on. Again, this is review how to describe curves, but more specifically, get familiar with this this sentence structure. Samples have a larger relative frequency around the mean, smaller standard deviation, that sort of idea. And then last but not least, know how to do basics of mathematics. If you multiply by bigs, your answer is bigs. If you multiply by smalls, your answer is just smalls. Divisions are opposites. If you divide big, your answer is small. If you divide small, your answer is big. Question 1. Compared to a normal distribution for a population, what differences would you expect when you construct a sample distribution of the same data? All right, so this is exactly what my picture was showing. All right, so again, the idea is this. This is your sample. This is your population. What differences do you see when you construct a sample of the same data? What I see is this. Do not shorthand this. Do not shorthand this. All of the words are meant to be there, and if you're missing some of these words, it's not going to be correct. So don't just say the relative frequency is bigger or something like that. No, you have a larger relative frequency around the mean. Like all of those words are meant to be there. Okay? A smaller standard deviation, not distribution, but a deviation. Deviation, not distribution, deviation. Number 2, what will happen to a sample distribution curve as the sample size decreases? All right, so here is the key to success. The sample size is AKA the n. So what happens to this n? N in this case is getting smaller. Okay, if the sample size decreases, i.e. n gets smaller. So what will happen to this curve? So my question is, what happens to this answer? All right, so again, this is the idea that this is a multiplication number, this is a division number. So what did I just do? I just divided by a smaller number. So what happens to the answer if you divide by a small number? Your answer is going to get larger. Because a division is an opposite. I just so happen to be dividing by a smaller number, so my answer is going to get larger. So my last bit before we get to the words is, well, what is this answer? What is this a symbol for? That is a symbol for the standard deviation. So my standard deviation just got larger. You need to show this mathematics to get a correct answer to this question. You need to show this formula and this breakdown. Make sure your arrows are pointing and coming from the proper things, showing the proper information. All right, so that's part of the answer. The rest is going to be the words. So what will happen to the sample distribution curve? You will get a larger standard deviation. And if that happens, that implies that you're going to have a smaller relative frequency around the mean. All right, this is asking for what is a probability, aka what is the area between 9 and 14. Notice how it's the regular x. So I get to do it exactly how I did the previous assignments. So this is, in essence, a setup where I have the number 9 and 14. And it's asking what is the probability, aka what is the area in between those two. So I'll start working with the 9. Again, make sure Z's round to your second decimal point. What was that? Negative 1.05, I think it was. Okay, negative 1.05. $14.69. Okay, do the same process with the 14. You know the probability between those two things, so that means I take the big area and subtract the small area. So room to work here. So the question is, what is the area in between those two things? So I take the big area minus the small area. There it is. Now the next question is the exact same question. However, notice that the middle is an X bar. So wherever I use the sigma of being 2.2, it's no longer going to be 2.2. I need to change the sigma to fit the idea that this is a sample and no longer a population. So before I get to work with z-scores and things like that, I need to know what is the standard deviation of my sample. And so that's going to be the standard deviation divided by the square root of n. So in this situation, that's going to be 2.2 divided by the square root of 5. So in this problem, it's going to be 0.8939. Excuse me, 0.9839. I'm sorry. 0.9839. That is my new standard deviation that I need to use. So I have to set up the problem so I get the correct results. So this is the keynote difference, and that's going to just change the mathematics. Not the idea of the question, but just the mathematics of it. So we're still finding an area between 9 and 14. Still need to do it the same way, XZ area. However, the only difference is we have a different standard deviation. So here, when I divide by sigma, I'm not dividing by 2.2, but rather 9839. So again, the question still remains, what is the probability of the area in between the two things? And so that'll be the big minus the small. All right, number 5. Why was the P of the x bar greater than the probability of the x? And here's the punchline. This, because x bar is a sample. Okay, because x bar is a sample. And so what I need to see as your answer is, well, one, you need to identify x bar as being a sample. And then what do samples have? Samples have a larger relative frequency around the mean. And a smaller standard deviation. Okay. Educationally wise, this is why. Take a look at an example of what these two pictures look like. This is the population, this is the x. This is a sample, this is the x bar. And so we have two arbitrary numbers here. We have the numbers 9, which is over here somewhere. And we have this number 14, which is over here somewhere. What percentage of the blue curve was between 9 and 14? What percentage of the blue curve was between 9 and 14? So again, you see this blue curve, and so yeah, a lot of it, wow, a lot of it is in between the 9 and 14. And so what we found was 89% of the curve is between there. But I asked the same question of the red curve. How much of the red curve is between 9 and 14? And it's damn near all of it. Okay, almost all of that red curve is between 9 and 14. There's just little slivers that are not. And so why is the red have a bigger probability than the blue? Well, it's because it's taller and it's skinnier. That's why. And so why was the p of the x bar bigger than the p of just the regular x? Well, because it has a larger relative frequency around the mean and a smaller standard deviation. That's why. Okay. What will happen to the sample distribution curve as the sample size increases? All right, so this is this problem right here. And what is happening? Well, the sample size, the n, is getting larger. So again, n is a division number. So if I divide by a larger number, my answer is going to get smaller. The answer being the standard deviation. The standard deviation will get smaller. And if that happens, then that implies a larger relative frequency around the mean. All right, number 7 is the problem with the regular x, so I don't have to do anything fancy. I just have to figure it out. Okay. The next one is the same problem, but this has an X bar, so I do the exact same process. However, because it's an X bar, I have to get a different sigma. So the sigma that I need to get in this case is going to be sigma divided by the square root of n. So sigma is no longer going to be 2.9, but rather 1.1839. Notice how the standard deviation just got smaller. And now that that's established, the entire problem is exactly the same. Is that right? Yep. Oh no, what did I just do? Last but not least, why was the X bar 7804 bigger than the X, the 3905? Well, because look at my handwriting. Again, it's a standard deviation, not a distribution.